There are only so many ways you can ask these questions. There are two types of special right triangles. There are isosceles right triangles, which is what this one is, and that's what this one is. Some people call them 45, 45, 90. It's the same thing, but they are isosceles right triangles. Two ways I can ask a question about this kind of triangle is I can either give you the leg or I can give you the hypotenuse. So what I'd like you to do is put a 1 here and put a 1 here. And put the x over here. Okay? Here, 30, 60, 90. Now if you remember, the 30, 60, 90, this is half of an equilateral triangle. This is 60 degrees. This is 30 degrees, right? If I reflect this across, this is a right angle. The side across from 30 degrees, I could give you that. The side across from 60 degrees, I could give you that. Or the hypotenuse, I could give you that. So what I want you to do is put 1s in all of those places so that now you have model special right triangles. These are models. Now remember, if you're dealing with a right isosceles triangle, you only have 2 variables to deal with. And if you're dealing with a 30, 60, 90 triangle, you only have 2 variables to deal with because 2a is equal to c. If this is an equilateral triangle and it's a reflection, this is also equal to 1. This side is equal to 2, and since it's an equilateral triangle, these sides are equal to 2. So the hypotenuse is going to be twice as big as the side across from the 30-degree angle. 2a is equal to c, where a is the side across from the 30-degree angle. Here it actually makes a difference. Right here, if you have this triangle, the Pythagorean theorem says that a squared plus a squared is equal to c squared, which says 2a squared is equal to c squared, which says that the square root of 2 times a is equal to c. How is that useful? Let's do it again over here. I know that this is 1, so now 1 squared plus 1 squared is equal to c squared. 1 plus 1 is equal to c squared. 2 is equal to c squared. Square root of 2 is equal to c. So down here, same kind of problem, right? I know that x and y are equal to each other. So Pythagorean theorem says x squared plus x squared is going to equal 1 squared. That's 2x squared is equal to 1. Square root of 2 times x is equal to the square root of 1, which is 1. I divide both sides by the square root of 2, so I rationalize the denominator. What else can I do? Well, up here, I don't have b, but I know that 1 squared plus b squared is equal to 2 squared. 1 plus b squared is equal to 4. B squared is equal to 3, and so b has to equal the square root of 3. That triangle right there, and this arithmetic right there. I know that this is the hypotenuse, right? And I know that it is twice as big as the side across from the 30-degree angle, so this has to equal 1/2. So 1/2 squared plus h squared is equal to 1 squared. This is 1/4 plus h squared is equal to 1. H squared is equal to 3/4. H is equal to the square root of 3 over 2. This one, a little bit more complicated, except that this is equal to 2f, right? This is twice as big as this. 1 squared plus f squared is equal to 2f squared. 1 plus f squared is equal to 4f squared. 1 is equal to 3f squared. Take the square root of both sides. 1 is equal to the square root of 3 times f. I got to divide both sides by square root of 3 and then rationalize the denominator to find out that f is equal to the square root of 3 over 3. So this is the square root of 3 over 3. And this is twice as big, so this is 2 times the square root of 3 over 3. So now if I show you this piece of paper, what a mess. But if I take this information, model special right triangles. If this is 1, this is 2, and this is square root of 3. If this is 1, then this is 1. This is square root of 2. If this is 1, this is 1/2, and this is square root of 3 over 2. This is 1. This was square root of 3 over 3. And this was 2 square root of 3 over 3. And if this is 1, this is square root of 2 over 2. And this is square root of 2 over 2. Those are the answers to what we just did, right? Why is that useful? It's useful because every 30, 90 degree triangle is similar to every other 30, 60, 90 degree triangle. What's that mean? That means that there's a common ratio among all of them. In fact, all 3 of these, you should be able to look and see what's the common ratio. If I looked at, say I look at this one over here, and I compare it to this one over here, can you find the ratio? What do I have to multiply the numbers here by to get these numbers? What do I multiply 1 times in order to get this number here? 2 square root of 3 over 3. Well, guess what? If I multiply this times 2 square root of 3 over 3, I get square root of 3 over 3. And if I multiply 2 square root of 3 over 3 times this, I get 1. That means if this turned out to be 7, this would be 7 over 2. This would be 7 square root of 3 over 2. If I had a triangle that was 30, 60, 90 and the side across from 60 degrees was 47, I'd have to multiply this times 47 to get it. Multiply this times 47 to get 47 square root of 3 over 3. Multiply this times 47 to get 94 square root of 3 over 3.